third lesson of our linear unit, and it is about nonlinear functions. So your expectation today, you're going to be able to graph points and decide if it's linear or nonlinear. That's what you can do today. Does it look like a line or does it not look like a line? That's it. So again, look at your learning target. You can identify linear and nonlinear functions, and we're not even worrying about making equations anymore. We're saying, nope, not doing it. Which should make you happy. So you need to know what I mean by non-linear. Non means like no line. Okay? It is not a straight line. It has a sharp direction change, or is, I don't know what I meant, or is curved. I bet I meant curved. So it's not a straight line. Not a straight line means that you're either changing directions quickly or you're all curvy all over the place, right? You're curving around. So not a straight line, has a sharp direction change, or it's curved. So some lines, now you can make your own lines, but here's a line. Is that a line, yes or no?
Yeah.
It's straight. It goes in the same direction forever. Directions. Here's another line. Do you think it's a line?
Yes.
Yeah, same direction. It looks straight to me. I could take a ruler to it. And you make, ooh, let's make a decreasing line. Like a hill. There's another linear, or a line. These would be linear, 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 linear. Now let's do nonlinear. Lots of different ways. We can make it look like a line at first, and then bam, just kidding, I'm changing direction. That's nonlinear. It doesn't continuously go in the same direction. That's the sharp direction change. This is also nonlinear. Any kind of curvature is nonlinear. There's too many curves going on, nonlinear. So do you think you can determine, if I gave you two graphs, and I already gave you the lines, would you be able to tell if it's linear or nonlinear? A lot of questions are on the MCA like that, believe it or not. They're going to say, hey, like they'll give you a choice. Is this linear or nonlinear? And you'll have to click. They'll put this one down, linear or nonlinear. You'll have to click. Nonlinear is not a straight line. Okay? All right, that's objective number 1. Okay, this is big. This is a big learning standard. Let me see if I need to get to it today, though. Okay, so the next one is looking at a table and identifying if the table represents a linear situation or a nonlinear situation. Linear means you're adding or subtracting the same thing constantly. We have talked about this. We have. Linear is adding or subtracting the same thing. It's finding that slope, that m, how y changes over how x changes. Nonlinear is when you multiply or divide by the same thing, or if there's no pattern. So linear is only when you're adding and subtracting by the same thing. And when I say by the same thing, I mean change in y over change in x. Remember that triangle means change, delta y over delta x. Okay. I'm not going to make you have to do it this way. Today I'm going to give you a table, and I'm going to say graph this table and tell me if it's linear or nonlinear. And then you use this knowledge to see if you're correct. So here I have plus 2, all the way down it's plus 2, and plus 1, right? All the way down. That would be linear, adding the same thing. What do I have here? Plus 3. Do you agree with me, yes or no? Plusing 3 all the way down. What am I doing to the x's? Plus 2 all the time? Linear.
Is that plus 3?
Yeah. Okay, what am I doing here?
Plus 5.
Plus 5. What's 9 plus 5 is 14. So this is nonlinear. Do you see how I check that? I always check to make sure it goes through the whole thing. Okay? Uh-oh, it's kind of backwards here, but no problem. Change in y first. Look at your change in y. Y is right here. Minus 1, plus 1. Right away, it's nonlinear. It's only linear if you're adding and subtracting by the same thing all the time. Okay, what do I got here? Plus 1 all the way across. Plus 1 all the way across. Is that linear or non?
Linear.
Linear, because I'm adding the same thing all the time. Okay, unfortunately, I didn't create a slide for the second part of your target. So you're going to have to write or, do you have any room? Or you don't have room, right? Or plot and see a line. And that's what I expect you to do today. I'm going to give you a table. You're going to plot the points and you're going to say, does it look like a straight line or curved line? For example, take your whiteboards out, flip it to the graph side. Don't crash on me. It's not gonna, don't worry. Hey. Okay. Now I expect you to apply both of these today. Because some are gonna look like a straight line because you have to scale it weird. So you have to use the strategy that we went through on our notes. Alright. I want you to plot these points and tell me if this is linear or nonlinear. Wait. I have to think. Is this going to be linear or nonlinear? But plot them first, and you're going to be like, but how? Today you're going to be like, how? A couple times, because you get some big numbers. You're going to have to scale it. See, that's the y. So what I would do is maybe go 5, 10, 15, 20, 25, 30, 35, 40. So 0 and 5, plot. 1 and 10. 2 and 20. 3 and 40. Does this look like a line? Does it look straight or curved? Curved, nonlinear. And that's what your homework is like today. Curved, nonlinear. Tatiana.
Which side do you grab from X or Y?
You always just plot the points like this, where it's always X first, then Y. Okay, so it's X, Y, X, Y. So you always go to the X, then to the Y. X to the Y. All right, you do another one. Don't put those away. I'm making you another one. Linear or nonlinear by graphing.
Negatives.
Oh, that's okay. Negative just means left. I have to think a little bit. Got it, okay. Plot and tell me if it's linear or nonlinear.